So if a function simply is increasing, then it is not going to have an absolute maximum, or even a local maximum. But if a function goes up and down, then it is going to have maximum, minimum. Then you can split intervals where it's maximum, where it's increasing or decreasing. What do I mean by that? Let's just take a straight line, right? It's a linear function. You look at that linear function and it keeps on going. Can you tell me if there is an absolute maximum or absolute minimum? Colton?
No.
No, because the absolute maximum, minimum would be infinity, negative infinity, but they're not proper numbers. So we do know that this function is increasing. So the function is increasing for all real numbers for x. So negative infinity all the way up to positive infinity, the function keeps on increasing. Who has seen the euro symbol?
Once.
Okay, what does that mean?
Of course you asked me.
Well, you gave me the answer.
I said
You
I
should have
saw
kept
it
quiet.
once before.
Anyone else?
It means that x falls within that interval.
It means that x is in that interval, negative infinity to positive infinity. So in or belongs to. Does this function have an absolute maximum?
Yes,
Yes. Where is it at?
right at the top of the first slope there.
So right here, it is an absolute maximum. So that is the x value where the absolute maximum occurs.
There's no absolute minimum seeable from that function, no, as is.
Is that one an absolute minimum or a local minimum?
Local.
It's local because there are smaller values over here which are less than that value. We call it local because it happens on that interval, and that is the smallest value on that interval, which is why we call it local. So that would be a local minimum. What about that point right there?
That would be a local maximum.
Is that absolute or local?
Local.
Local, because that is the absolute maximum. So this would be the local maximum. So the absolute maximum happens at x1, a local minimum happens at x2, a local maximum occurs at x3, and those are the corresponding y values. Good? With me? Now, see the difference between that function and that one? So if I look at that function, we've already concluded that it is increasing for all values of x between negative infinity and positive infinity. Could I make the same conclusion here?
Nope.
No. There are pieces where the function is increasing, which is right there, and right there. And there are pieces where the function is decreasing, right there, and right there. Good? Now, the objective is to find those increasing and or the intervals where the function is increasing or decreasing. We're going to use calculus to give us that answer. With me?
Yeah.
Now, what is the basic idea? What does the derivative tell us? Going back to the very beginning. It is a rate of change, huh?
The rate of change.
Rate of change specifically, is it average or instantaneous?
Instantaneous.
Instantaneous. So, in other words, it is the slope, agreed? At any given point. What happens, what is the slope right here? Is it positive or negative?
Positive, because it's
How about
rising.
that?
Positive. 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 Zero.
Zero. Very good.
Negative.
Negative, 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 0, positive, positive, sorry. Kind of butt in there.
Sorry.
I kind of butt in there and I heard it speaking and I overheard.
Oh.
Yeah.
0, right? So, the idea is quite simple. If we determine places where the derivative becomes 0, then naturally we will know where the function is going to be increasing or decreasing. That's it. Right? So the goal is to find points where a function would be 0. I'm going to show this using a calculator as well as, the manual approach. Calculator is your friend, so you're welcome to use it. Can I erase this? Critical number or critical values. Now, why are they so critical? I didn't know my course came with sound effects. It would be nice if I started every problem with that low and order introduction. Dun dun. Okay, is a point where the derivative I'll explain the D&E part later. There is a reason why we have D&E. So pretty much the critical number tells us, okay, the derivative is going to become 0 at a critical number. We've already addressed here, if I found the points where the derivative is 0, it will correspond to minimum or maximum. The moment we determine if something is a minimum or maximum, the function has to go up, come down, go up. It has to happen. So to determine increasing and decreasing or intervals where a function is increasing or decreasing, all we have to do is find the critical numbers. Yes? Okay. What is the derivative? That is the very first step. Derivative of x, or derivative of f of x, I mean.
3.
3. So what does the critical number, or how do we find the critical number? We take the derivative, we set it equal to 0, and we determine the value of x where it becomes 0. So step 2, we set the derivative equal to 0 and solve for x. The derivative is 3, and could 3 equal to 0? Not going to happen, right? So, in other words, a critical number just doesn't exist, but it is actually undefined. Doesn't exist, perhaps takes or definitely takes a different meaning, so I'll just say undefined. We cannot find one. Can someone tell me why this failed?
Because it's a constant line. It's a slope that's going up at a constant rate. There.
Right, it is a linear function. Positive slope. Slope is positive, implies increasing line. The very first case that I did. And we know something about an increasing line. An increasing line is increasing for all values of x from negative infinity to positive infinity. Good. So that's why it didn't work out then. What type of function is that? Okay, so first step to do is to graph. Press y equals. Now I'm going to show you the easier way. Of course, this is easier also, but I'm going to show you using the calculator first. You haven't answered my question. What type of function is this?
Like a FOIL?
FOIL?
Yeah, if you like take it into parentheses.
Okay.
I was going to say polynomial, but
It is a polynomial, but it's a second degree polynomial. Starts with the letter Q.
protein.
Huh?
Oh gosh.
Quadratic. It is a quadratic function. If you sketch a quadratic function, what should it look like? You know, a parabola. And this parabola is going to have a minimum, and if it has a minimum, you can split and see where the increasing and decreasing intervals are. Yes? So clearly there is a part where there is a piece of interval where the function is decreasing. There is an interval where the function is increasing. Now, if you press second trace, which would take you to a set of options, and you scroll down, what do we see in the picture? We see minimum in the picture, right? So let's hit 3. And it is going to ask you for 2 endpoints to make a guess. So I'm going to go to the left of the minimum that I see, hit enter, move to the right of the minimum that I see, hit enter, and I'm going to make a guess. So enter. So it tells me the minimum is at 0.499999, which probably is 5. Do you agree? 0.5. And what is the value of that minimum? The y value of the minimum?
0.75.
0.75. Good. So we found the minimum and we found the value of the minimum using the calculator, which is right over here. Let's see if we can use a bit of calculus to find this. What is the first step?
Derivative. Find the derivative.
Find the derivative. What is the derivative of x squared?
2x.
2x minus 1.
Derivative minus 1, and the derivative of 1 is
0.
0. What is the second step?
Solve for 0.
Solve for 0.
Set the derivative to 0 and solve for x.
Set a derivative equal to 0. And we solve for x. Now, 2x minus 1 equals 0, which would imply 2x is equal to 1. Divide by 2 on both sides. 1/2. Isn't that much with that? Now, how do we find this corresponding y value?
Well, x equals 1/2 into the original equation.
All we have to do is take this 1/2 and plug it in there. You will get 0.75. Does that make sense? Okay. And you may ask this question, well, that's just silly. If the calculator can do this, why do we even need calculus? Well, the calculator is able to do this because we knew calculus. 2, sometimes the minimum and the maximum may not be visible to the naked eye. In the sense, depending on the settings that you have in the calculator, you may be able to see it, you may not. You may be able to see it, you may not be able to see it. And the only way to know where to look is given by calculus, right? So it tells you, okay, you have to look between 0.3 and 0.5. It sort of gives you the idea as to where you need to look for. So now that we have obtained the critical value, I'll do one more example or two of finding critical values, and then we can get into increasing and decreasing intervals. Let's see. I'll give you a minute or two. If you want, you can use your calculator first, or use the derivative and give me the answer. It's entirely up to you. Okay, who's got the answer? Liam?
from what I got, the minimum is about 1.25 of an x value, and the y value is negative 7.55.
Okay. He said about, and
Well, I got something different than that. I got x equal to 2 and y equals 0.
x equals 2 and y equals 0. Okay. Anything else?
Oh, I didn't really know where to go after I put the derivative equal to 0, because if 4x cubed equals 0, so I divided by 4. Does that make sense? And then I've had to take the cube root, I guess.
Why is it 4x cubed equals 0? What is the first derivative?
Oh, I'm sorry. It was 8. I see the problem. I'm going to put an x in there.
4x cubed minus
8.
8. Liam was very close. If we set f prime of x is equal to 0, then we would end up getting 4x cubed minus 8 equals 0. Move the 8 to the other side. We have 4x cubed equals positive 8, which would mean x cubed is 8 over 4. 8 over 4 is 2. If x cubed is 2, what is x? You have to take the third root on both sides. The third root of x cubed is x, and this would simply be the third root of 2. You can use a calculator to find that. And what do you get for the third root of 2? Should be 1.2.
How do you type it in so you can make like the third root sign?
It depends on the calculator, but most calculators would respond if you put 2, the caret symbol, and 1/3.
There you go. Perfect.
What do we get?
7.559. Or no?
The third root of
1.2599999.
Come again?
As he said right there, 1.2599.
Okay, so we'll call it 1.26. So if we use the calculator, we have y equals, the function here is x cubed. Or was it 4x cubed? No, it's x raised 4. And you say something like that, it sort of is obvious, right? It's close to about 1 something. So we could do second trace, number 3, which is minimum. Left bound, right bound, guess. 1.2599, and the value of y is negative 7.559. Does that make sense? Any questions on how to use the calculator?
Does it have to be specific points on either side, or is it just one, like clicking one side on the left kind of close to the bottom and one side on the right close to the bottom?
Yeah.
Okay.
You just have to make sure that the minimum is captured. So you're telling the calculator, okay, I see the minimum there, so let me go to the left of the minimum, right of the minimum, and ask the calculator to guess the value for me, and it'll just give me. Are we good? Again, these days you have a calculator, and because of that, life is easy. But even with a calculator, there are certain functions for which you may not be able to recognize the minimum right away or the maximum right away. But if you use these steps, you can find it easily. Good? Okay. I'll give you about a minute or two to do that. This problem is a nice lead-in to increasing and decreasing functions. So when I start next time, I'm going to use a problem similar to this, or the exact same problem, to explain the concept of the increasing and decreasing part of the function. Okay, do we have an answer?
I don't know if this is right, but I got 0.83 for x and negative 0.06 for y.
For what? 0.83 for x and negative 0.03. Okay. Anyone else?
So for the X I got 0.2886,
Okay.
and for the Y I got negative 1.924.
That sounds better to me. What did you use? Did you use a calculator
I
or?
used both.
Huh?
I used both.
You used both? Okay. How many of you used the calculator?
I used both, but I got the answer with the calculator, not.
Maybe we should call this course How to Use TI-84.
I did it all the way up till when it was the derivative equal to 0, and then I used the calculator, so that's probably where I screwed up.
Yeah, that should be fine. Let's see. First step is to do
Derivative
derivative,
of x to the second power.
which would be 12x squared, yes,
Yes, minus 1.
minus 1. Step 2, you set the derivative equal to 0 and you solve for x. So 12x squared minus 1 equals 0. 12x squared would equal to 1, which would mean x squared is 1 over 12, yes? How do we solve for x? What should we do?
Square root.
Square root on both sides. Square root of x squared is x. And square root of 1 over 12, we could also write this as 1 over square root of 12. Yes? Which I believe is going to be close to bracket answer. What is it?
0.2886.
Where did you go? What's your name?
See, it's the Google calculator that screwed
That's
up.
why you
Yeah,
have to
I
use
know.
a real calculator.
But I got up to that point, they gave me the wrong answer from square root.
So we have to be careful about something in this problem. Can someone tell me what?
If x is positive or negative,
Why is that? What's your name?
silence,
Silas, why is that?
because it's the square root.
It's a square root. So if we have a square root, we shouldn't forget the plus or minus part. So the answer is technically plus or minus. If you graph this function, Are you still able to see with the lights on? Can you see?
Yeah.
Okay. Full x cubed minus x graph. Right? It's a nice little function, but if you look at the graph, you may get stuck on an example when you do the homework. Why?
Because you can't see it.
You can't see it. So you have to sort of go back and forth, adjusting the window, trying to exactly find where the minimum or the maximum is at. If you're an expert, go for it. But if you do this step, it sort of tells you exactly what to look for. It is telling you that there are two critical values, one at negative 0.2886, the other at positive 0.2886. That should tell us, okay, maybe I will set the window for x values from negative 0.28 up. Negative a little bit to the left, 0.5, little bit to the right, past that value, and we have to change the y also. You see all the things that we have to do to find the answer. Might be smaller than that. Right? Now you see the points, but had you not known this bit, you'd be sitting there trying to play with the calculator and freaking out because, hey, I don't see a critical number at all. The moment you do this, you can verify your answer by adjusting the window in the calculator to see if you did the right process. Is that making sense?
So the only way you get to that is you play with it, you put in graph window.
What's your name?
Ajamon.
Huh?
Ajamon. AJALON.
Ajamon.
Ajamon.
So
Just call me AJ.
AJ said, well, the only way to get to this is should we just play around and try to find it? That defeats the purpose of calculus. You know the answer already.
Yeah.
Here. I don't need that at all. I'm just trying to explain that to you so that you can verify your answer. This is the answer. You know the critical numbers are negative 0.2886 and positive 0.2886. And I can be 100% certain about this. This is the correct answer because we didn't make any mistakes. And I can find the corresponding y value by taking this and putting it back in there, and I'll be done. I'm showing you this so that, I'm showing you that the calculator is your support system. Even if you want to play around and you say, well, I don't want to do any of this, I'll just sit and look at the calculator and play around. That process is going to take you about 10 to 15 minutes. This, on the other hand, about 2 minutes. It's a matter of efficiency. Are we clear? Okay. Next time I'm going to pick it up from here, and I'll show you how to find increasing and decreasing intervals of the function. If you have any questions, talk to me. If not, have a good day.